There we go. Okay. Hey, how's it going, everyone? Welcome on in. We are going to be building our Pytorch tutorial. We're going to get our LSTM training today. That's the plan. We have a smidgen of time. I think we can do it, though. I think we can actually finish it today. It's a week worth of long short-term memory models that we are getting going here. All right, so we already got the training model defined. The training, so we do model.train. Can we do that? Can we do, actually, I'm kind of curious. Can we do this? Is this can we use it as a decorator? Can we use that as a decorator? I'm actually curious about this. Or is it going to be like, no, you can't do that? It's like, nope. Why would you be able to use that as a decorator? Of course, why not? Training mode is expected to be a Boolean. All right, well, what if we did this? How about we do that, all right? We'll just run it right there. That's it. See, there you go, right there. All right. Okay, so one of the problems was our output, what do you call it? The criterion, when we compare it to our targets, was failing because we needed to also compare to the length of the output because we're doing a word level output, right? So we need to also make sure that we grab that. I think that was where we had a problem. So get our outputs here. The answers are here. Is that what this looks like? Oh, we're argmaxing 3. But however, I'm not sure if that's correct. Let's print out all the answers real quick. Our answer output. Let's print out the answer as well. Hey, Zergio, how's it going? Thank you for clicking the hi button. Welcome on in. Good to have you here. We're going to finish this LSTM today. We're going to become Pytorch experts. That's what we're going to do. I need to see what this is right here. This is what I need to see. This right here. So let's see what that looks like. That looks like this, which is a bunch of numbers. Yeah. And it's the length. All right. So it's a classification. So we have 3 classes and the number of words. 1, 2, 3, 4, 5, 6, 7. There are 7 words. The mask, however, is different based on the length. So if we're actually going to do some comparison, we also have to take the mask into consideration because it's going to give us the answers to words that don't exist. Hey, how's it going there, Bryce? Good to see you, Bryce Hickman. Thank you for saying hi. Welcome on in. Happy Tuesday. All right, so now that we understand what our output looks like, if we do an argmax, it's not doing exactly what I want, right? Because if we look at it, this is 4? No. Oh, wait, 4. No, oh, it's argmaxing based on the maximum. Okay, so we have to do it differently. So we have to iterate over all of our answers. So this is a batch, right? And then if we wanted to use that for our back propagation, we need to also have our targets correctly formatted. So we don't currently have that. We do not have that right now. Right here. These are our targets, our labels. Let me double check because we almost got it working. Howdy, friends. Hey, Bunzoopy. Good to see you. Welcome on in. Happy Tuesday. Good to have you here. We are very close to being able to create our first gradient. Oh, we're right there. We're right there. Our first gradient. So close. So let me print out our labels really quick so I see what they look like. They're right here. They're already being printed out right here. So I should already have them up here somewhere. That is quite a few outputs there. That is a few more outputs than I was expecting. Wait, why are there so many? This might not be the thing that I thought it was. Wait. All right, so let's look at this. So we got 1.1037. Let me bop down here. It's the same. Okay, so it's repeating. What about, so it's 8846 of the same? Yeah, it's the same. Is it repeating on purpose? Wait, shouldn't it not be? So I see the output. It's just a little bit more than I was expecting. This is, all right, let's think about this for a second. So this is what our input data is. This is our features, right? These are our features. So with our input data, we need to, I need to think about this for a second because it's not what I was expecting. Because there's a few extra things. Oh, you guys, it's right here. It was right here. That's what the problem is. It's not a problem. Okay, we're good. Okay. I was worried. I was worried for a second. I'm like, why am I seeing so many numbers on the screen? It doesn't make any sense. It makes sense now. It makes sense. It's because we're putting it in a for loop on the number of epochs. So let me set the epochs to 1 until, so that way it doesn't confuse me. I'm gonna be confused. We should also print out our loss, and we on the print epoch. Let's do this. Let's do it with an F string. So F epoch, and then we say equals, and we will print this like that. So that way it's a little bit easier to see where we're at. All right, let's run this again. No, that's perfectly fine. It's perfectly fine. I was going there. Abdurasul, welcome on in. Good night, Stephen Blum. Very late stream. Yeah, we're doing some late streams today. Hey guys, how's it going there? Welcome on in. Good to have you here. Happy Tuesday. All right, so now we're at it. Let's do a plot. Can we do an epoch +1? I think that would be better. +1. I'll say epoch equals like that. Do you own a cat? Tiny Lion Gaming. How's it going, Tiny Lion? Well, I used to have a lot of cats. A lot. And my best friend Sam, he's got a cat as well. He's got a cat. I do not have a cat, is what the answer is. No, I currently do not. Not currently. My grandmother ran over my cat. The last cat I had, my grandma, she ran over. I'm dead serious. She did, and then I didn't hear about it for a long time. I'm like, where's Kitty Cat? Where's Kitty Cat? Where's the Kitty Cat at? I don't know where the Kitty Cat is. Oh, poor kitty. I know, Bunzupi. I know. Justice for the cat. I know, you guys. I know, poor kitty. I know. Where's the Kitty Cat? Well, we have something to tell you. Your cat was sleeping under the car. It was the cat's fault. It really was. That's what happened. It was the cat's fault. It was sleeping under the car. We got in the car. We turned it on, and we started backing out. And what was that? What was that? Oh no! It was Steven's cat. It was Steven's cat, you guys. Oh, that was that really happened. That really did. That really happened. A long time ago now, though. That was quite a while ago. So I haven't had a cat since. All right, so where are we at now? I want my... Now that we have our correct data format, how did you cope through it? Well, I didn't know about it for a few months. Like, where'd the cat at? I was very understanding. I wasn't like... I didn't throw any emotion towards my... There was no purposeful intent there. The cat was sleeping. The cat was like, the tires are probably warm, right? Because, that's what cats gravitates towards warmth. So I couldn't. I was very sad about it, though. I was very sad. I'm like, no. No. I was very sad. All right. One second. Okay. Let me pull this back over here. Okay. So I'm curious how you are having instant text-to-speech. Isn't that pretty neat right there? Isn't that neat? Check that out. Instant text-to-speech right there. Isn't that pretty nice? Actually, if you look at the video and you record it and you really look, sometimes the text comes before I speak. He wrote his own OBS plugin. I sure did. I always have it up here because y'all are always ask. So it's right here. Easy to install. You just enable your microphone. And then you copy the URL and you paste it into the OBS browser extension. I sure did. It's not text to speech though. It's speech to text. Yep. Thank you. Speech to text. You're right. Speech to text. Got to get it the right way. It's speech before text. Yeah, exactly. The speech comes and then the text comes. Yeah. So it's really easy. You just put it into your browser. And this was like 8 years ago. So it still works today. Mind blown. I know, isn't it neat? It's great. Instantaneous. Yeah, it's right here. We support multiple languages. And you can have all these different shapes and styles, patterns. Really easy. There's a NanCat version right here. I'm being pedantic. Speech to text. Got to get that speech to text. Yep, got your NanCat mode right here. You can do that as well. Yeah, and also if you want one word at a time, it's right here. You just copy this format right here and it gives you the one word at a time to make it really easy. Yep, there you go, you guys. Okay, let's go back to our tutorial. Stephen, can you add speech to text Russian? Yes, it supports it. It supports it. It does. All you do is you just put in the right language code, and it should already support it. I know it says, Spanish, Mandarin, German, and Japanese. It does have Russian. It does have Russian. You just set the language code. These are some examples. Here's all the supported language codes. Here you go. I'm gonna tell you what. Rusi, are you right there? It's supported. Hey, Torba, welcome on in. Good to see you. Happy Tuesday. Yep, supported. It's got. I linked to it right here. You click on this right here. All the language codes, everything in it probably works. I couldn't tell you for sure though. I'm pretty sure it does work though. I'm pretty sure. Okay, let's bot back into our tutorial. Now that we've got all of our data, what we need to do is, let me double check here. Okay, so we are getting a batch of our output. Nice. Yes. Wait. Oh, no, this is this. Okay, we're good. Nice. Yes. Okay. So this is exactly what I want. Now we can back propagate, and I think we can do it with the 3D tensor. I think we can. I think you can even do 4D tensors if you want. We're doing clear. Exactly. How's it going there? Samal, good to see it. What are we doing today? Becoming Pytorch experts. You got it. Exactly. You mean like live English to Russian translations. So we don't currently have the translation. However, we could add it. We could. We know how. We could make it happen. We can make it happen, you guys, if you want. That's something. Actually, we will plan on doing that. Okay, so that'll be something that we do later in stream. So maybe in a few weeks, we are planning to do something like that. All right, let's put that on our list. I think it's a good idea. Good idea, you guys. I'm really excited. We're going to have some upcoming streams here where we're going to be covering some pretty neat patterns that I can't tell you much about right now. When we do, though, when we have it, I'll be really excited to tell you about it. Doesn't Pytorch support arbitrary high dimensions? Yes. You can have as many as you want. We tried it. We went up really high. Hey, Ibrahim, what's up? Good to see ya. Welcome on in. Happy Tuesday. Let's become Pytorch experts, you guys. Let's do it. Let's make it happen. All right. So we got our output. We're going to answer, right? And this isn't exactly what we need to capture to see what our actual answers are in order to compare them. So how do we do this for our output? Our labels need to be different. That's what we got to do. Here, print labels. I need to see this really quick. Let's take a peek. Okay. So the answer is going to be the argmax for each of the words, which is very weird. I think it's very weird. We can do it though. So the answer is the argmax. So what we need to do is, it says 1 to 3, which is too many. There's too many tags because there's 0, 1, 2, and 3. So did we make a mistake somewhere? Here it is. Okay, there we go. We need the argmax. That's why, you guys. Nice. Wait, no. Wait. Oh no, we have to delete the dictionary. RM LSTM star. There we go. Now we're good. Yeah, there we go. That's what I'm looking for. All right, we're on the right path now. That's the output that we need right there. Okay, we're on the right track. Oh man, I need to catch up on this. You've mostly been using Pytorch. That the AI write. Oh yeah. You can have the AI write Pytorch for you. You don't understand most of the time. I know, and so you don't touch it. Hey, that's what we're doing here. We're trying to understand it. That's what we're doing on this channel. When you worked in industry, what does you specialize in? What do I specialize in? So I'm still in industry. I'm still live in industry right now. So I'm Stephen Blum, CTO over here at PubNub. We've raised 134 million, Series E, 1 billion devices on my network, 68 patent claims granted, 25 years in tech. We're still in industry. It counts. Hey, how's it going there? The Dreamer. Good to see ya. Not Claude, not RUX, the Dreamer. We got the Dreamer, you guys. Okay. Yeah, so I'm still in industry. And you said, when you worked in industry, what is you specialize in? Distributed compute. That's what I specialize in. Distributed high concurrency compute, where you have, thank you for the party poppers, appreciate it. Where you have a lot of devices online. Right now, 1 billion devices right there. That's high concurrency, isn't it? That counts as high concurrency. What's the secret of staying so young? Vegetables. Yeah, eat the vegetables. Water. Check it out. Right here, you guys. You got our water. Based. I know, right? Based. For serious, yeah. So I do. I seriously did. I eat vegetables all day long. Not a little bit, a lot. Basically all vegetables. You know, like Brian Johnson, who's the Live Forever guy. I'm serious. I'll show you. Let me see. I should have some pictures here. I'll show you. I'll show you what my daily vegetables are. I've got them around here. It's been a while. I need to take another picture. Here we go. Daily vegetables. I don't know if you guys can see that very well. There you go. See the picture? Daily vegetables, you guys. Make sure to eat them. Oh, what you could do instead is eat only vegetables and live happily ever after. How about that, you guys? How about that? Eat only vegetables. You could do it. You could do it. Steven, you're near to your startup idea. So near the future, you will DM you. All right, we'll talk. Sounds good. The Dreamer. Buns, if you know to manually tweak hyperparameters in Pytorch training scripts, wouldn't be able to write it out from scratch. Oh, got it. Yeah. So that's what we're trying to do here on this channel. My skill, I want to be able to fully write out everything from scratch. And we're actually getting pretty good. We're getting pretty good. You like your vegetables? Mooing like the cow? Okay, yeah, got it. Like a cow? You got cow moo? All right. So meat. Well, you're technically eating the outcome of a product that has consumed vegetables. Right? So does it count? I don't know. All I can tell you is I feel really good. I feel really good from a health perspective. Okay. So I need to, now that we've got our correct data, I think our criterion should work. Let's see if we can do it. Delta print, and then we're gonna run our optimizer. All right, Pytorch. Dude, darn it. Okay. That should work. Oh no, it won't. It won't because we have to do this. We have to do arg. Okay, so we did it. Oh, I get it. We don't have the correct matching shape yet. Okay, let's do that. Let's do the correct matching shape, you guys. Okay. Output model. So this won't work here because it's the argmax of the entire thing. And it's wrong. So what we need to do is we need to loop. We need to grab the argmax for each word. So let's rerun this really quick. So you see here, let me make that pretty again. So you said you specialize in high concurrency computing. Yes, I do. You're right, Bonzupi. And now you're learning Pytorch. Are you thinking about building like a crowdsourced AI training network, similar to how folding at home worked? The protein folding. Bring your computer onto the network so we can solve the world's most challenging problem with distributed computing power. Are you creating the data for the AI to train on? Yes, we are. Hey, you kind of know what you're talking about. Yeah, you sure do. Yes, we are. So right now we're getting the data in the right shape. AI is very particular about what data is on the input side, right? It's got to be all numbers and it's got to be the right shape and the right dimension. It's got to be. And the numbers can't be too big or too small. Otherwise you got problems, right? So yes, we are currently dealing with data. You can run any open source self-hosted AI model from Ollama. Yeah, you can on your 8GB RAM laptop. Not all of them. So some of them are pretty big. You have 2GB of NVIDIA graphic card. Okay, so you will have a hard time running. Some of these models require quite a bit of memory. You can quantize them, and I don't know if it goes down to 2 gigs. You might need something that's closer to 4 GB, right? For some of the better models. You recommend DeepSeek R1 2 billion. Would that work? Would that fit? Would 2 billion work? It sounds like it might, right? I don't know. I don't know if it would or not. I think 2 billion, maybe you would. Quantize the Tribe 2 from 8GB down to 2GB. Ooh, and then it will only just fit on your 2GB. It will only just fit. Thank you. Yeah. All right. So you guys, let's get into the correct data format because this argmax right here, you see that whoop, not there. This one right here. Right here, the 13, that's not going to cut it. It won't. It's not going to work. It won't work. It doesn't fit. So we have to make sure that fits. All right. So that's currently what we are focusing on. So I think we can get started here on that. Okay. Let's get into it. So how do we do that? We need to create a new. So we got our output here, and it's currently on tensor mode, which is fine. I think we can keep it in a tensor. We just need to mutate it to get the argmax, and we need to loop over it. How do you loop over something without detaching it? Can you do that? Wait. The argmax might have a dimension. Can we do that? Can we do that? Yes, we can. Yes, we can. Look at that. Oh, we know what we're talking about here. All right, is that what I really wanted? Let me see. So it's not. Let me think about this. Maybe we need to do dimmed 2. Let's try this. I don't know if that's the correct dimension. There we go. There we go. Look at that right there, you guys. Boom. Boom, we did it. Boom, we did it. Look at that. We know how to program here, don't we? All right. Contact equals or greater than content. The contact. I gotta get that. Well, we're making our way. We're making our way. This is so good. All right. For live detection of manipulative content that might hurt your brain if you consumed too much. Ah, yes. Yes, I see. If it makes you too happy and you're sitting there and you're scrolling and you're like, and it's too much, it's going to keep you invested in it, won't it? It's too good. Sorry, the app is too good. You have to discontinue your use. Right? That's what you're trying to figure out. Oh, you have a question? All right, what do you got? Abdurasul. It's not exactly related to the topic. In all of your videos, you only stream while sitting in front of your computer. Yeah. If you have time, could you stream your home where you live so you can dox me? Figure out where all the thing. I can. I'll do some. I'll do a smidge. So there was. Let's see here. All right. So maybe what I could do is I can show you some of my pictures. Here. I don't see. Let's see if I can zoom. Can I do this? Oh hey, what did you guys do? Mannequin TV. Thank you for subscribing. Welcome on in. You joined the right channel for software engineering. We do a lot of AI on this channel. Here you go. I don't know if you can see that very well. This is my office right here. This is what I see you guys as. You guys are right here. That's where you guys are. You're right there, you guys. We could do some more though. We could do more later. I can show you more later. Let's see here. Despite the similarity of your name of two bonsai, there is no affiliation there. Ah, yeah. Just a bonzupi, but not a bonsai tree. Not the tree. If you notice, then YouTube is doing something big you can see in your posts in LinkedIn. Really? What are they doing? Hey, Rock VR, good to see you. Welcome on in. Don't do that, Steven. It doesn't take too much to track someone down on Zillow. Exactly, right? So you can get doxxed, right? So I'm just going to show you just the room. Last stream I came to watch. Hey, you made it. You're good to go. Wood plank, the colors and the light reflecting on it. It's on Earth. Somewhere on Earth, yeah. How's it going there? Mick G. Lucky, welcome on in. Luke, good to have you here. Hey, Mr. Dungwall, so you're the guy with speakers on their setup? Yeah, but you know what? I'm looking at them right now. They're over here. I don't use them. I don't turn them on. I don't. I feel like I need to use them more or put something else there. Forever, Rock VR. Hey, look at that. We got our data in the right shape. So now what we can do is we can get our criterion going. We can get our loss. Look at that. Yeah, we can. Can we do it? Yes, we can. It's definitely going to work now. No, darn it. No. Yeah, no. All right, so it's almost off. We're like off by 1 or something. We're off by 1. We'll figure it out. That should work. That should have worked. Can't wait for the Elon to go to Mars and have a wait, what? A Martian guesser? Oh, like GeoGuessr? Like GeoGuessr? Yeah, but on Mars. I think that's gonna be hard because there's nothing there right now. Or really easy because the data set will be super small. You're proud of your work? Oh, I want to be in machine learning, but confused of roadmap. Hey, I know it's challenging. There's so many things, so many different algorithms, so many new things that are happening. It's hard, it's difficult to challenge. It sure is, you guys. The last stream for you. Oh, Rock VR original? Last stream? What do you mean? What do you mean? All right, let's check out this. All right, the Dreamer. I'll miss you. What? Where are you going, Rock VR? Where are you going? Why is it the last stream? 0 here. Okay. YouTube is currently testing Glass Morphism UI. Oh, is it? All right, here we go. So, you said YouTube is currently testing and rolling out a redesign of the video player. Oh, nice! Frosted glass, translucent elements, and create a glass morphism aesthetic. This update, which began global deployment in October last year, features floating rounded control buttons and semi-transparent backgrounds that allow the video content to show through. Oh, nice! Design choice widely noted for visual similarity to Apple's liquid glass. Nice. That's great. Reasons you can't say. Rock VR. Oh no, that's terrible. Proud by Core. Good to welcome on in. Good to see you. Apparently, Rock VR can no longer spend time with us. See the images? All right, you got the join button there. The sign in button. Oh, and you got some the mobile view. You got the mobile view. Nice. Nice. Very nice. You're very much into user interface. Bye, Rock VR forever! Oh no! All right, well, hopefully we'll see each other again someday. Rock VR. It was great to have you here. It was. Okay. Come back someday. If you can. If you can. All right, so now that we got our criterion, we need to figure out why it's not properly doing what we want. All right, so where is our loss? So, okay. Okay. Here is this. Let's undo. Where's our, here, oh, this right here. Here we go. Let's print this. So these two need to match right here. So those two need to match right here. So let's make sure those match. All right, let's try matching those guys. Let's try matching them. Before we do that though, the criterion isn't criterionizing. So I want those. Here we go. All right. You're getting this new update early. Why? Can you explain to me? Well, you said they started rolling out last year, right? So you're part of the batch. You're part of the batch for the users who are getting the new experience. You just got in. You got in early, the Dreamer. You got in early. Oh. Do we need it to be a tensor? No, it is a tensor. It is a tensor already. No, it's not. This is not a tensor. Those are our labels. But I made them into a tensor. So it should be fine. You know, here's what we'll do. We'll do tensor. Torch.tensor. There we go. Let's try that. Let's try that. Also, I think our negative log loss need. Thank you for the heart, you guys. Thank you for the hearts. I think we need it to be a floating point rather than a integer. So we need to change that as well. That might also be something that we need to do. We might need to do that as well, you guys. So I think we need to say, comma, dtype equals torch.float32. Can we do that? Is that something we can do? I know. Thank you for the reactions, you guys. Good to have you here. Let's keep going. So we are good on time. Also have a last week, I got early glimpse of the glass blur in their video player, but you forgot to take a screenshot. No! That would have been really neat to see. Thank you for the reactions, you guys. Okay, I want... Yeah, thank you for the heart. I see them. I see the floaty hearts and the party poppers. Thank you, you guys. Okay, I want to... Let's rerun this really quick. Is that correct? Okay, so now it's in the... It's a floating point. And then we should do the same thing up here as well. We need to retorch it. We need to... Do we though? Do we really? Do we really? I think we might need to. Okay, let's try it. So I want to hide that. And we're going to say torch. Is there a way to transmute tensor? Can we say .2? Oh, we use the .2 like this. .2 torch .float 32 like that, right? See, I know we know what we're doing here. Check that out. All right. Hey, those shapes look good to me. They look good to me now. All right, AI framework. Is this good enough for you? Is that good enough? It better be. It better be. Although we'll find out. We'll find out. Also, last we get okay. I think the YouTube is focused on lock. Yeah, it is. It's focused on you. It knows. Update light positive joke. It knows. Thank you for the reactions, you guys. When you do the reactions, I can see them. Here, I'll show you. See, this is what I see when I see your reactions. Steven, as CTO, how are you balancing between work, streaming, and managing everything? You are incredible. Oh, well, thank you. Appreciate it. While streaming, what I'm doing is something that I'd be doing while I wasn't streaming anyway. So we've gone over many years, I'd say since 2014 is when I started learning AI, right? So that was 12 years ago or so. I wanted to become an expert in AI. So I really dug into it. That was before any frameworks were real, before they had any real substance or traction. I needed to learn how to build it myself. So I did a feed-forward neural network, mean squared error, back propagation, gradient, stochastic gradient descent, and I was able to create models, and I did a good job. And I made multiple, and I was very happy. I even found out that you could change how the bias works across these models and how you're approaching your gradient adjustments, your weight adjustments with your gradients. It's very flexible. It's kind of however you want to do it. And in these frameworks, they have their own approach. So I never learned the frameworks. So what I'd be doing, if I wasn't on stream anyway, I would off stream be learning this. So instead I figured, why don't we stream this, you guys? Why don't we stream it? And then I can talk to you and you guys can catch my mistakes and we can learn together. So I'm actually benefiting. I'm benefiting from this. Cool. Captain Teach. Yeah, very cool, right? You heard the Cronus AI model. Oh, artificial superintelligence. Did they really? Wait, are you serious? Did it happen? Did it already happen? Superintelligence, you guys? Thank you for these reactions. Okay, so you saying, how do you, let's see. Yep. Different time zone, how manage your stream and work. What we do is we don't have a personal life. That's how we do it. We just don't have one. There you go. There's your answer. Work really hard. Work really hard, you guys. Okay, let's keep learning. The shape is correct now. The shape is correct. All right, let's do this. Let's bring this over here. So we have everything in the right spot. And then our labels. I want our labels to be labels. Okay, perfect. So let's do labels. All right, so labels equals. Let's update them. Let's replace them there. All right, so we get our labels. And then our features. Let's go ahead and do the same thing with features. Features equals. So that way it's a little bit easier to read, you guys. Gotta keep that easier to read. There we go, features. And then we're gonna grab this and bring that there. There we go. Thank you for the hearts, you guys. Appreciate it. I am curious about the artificial superintelligence, the Kronos model. I'm very curious about that. All right, so we've got our output. We've got our answers. And let's confirm that it works. No, what'd we do? We messed it up. We messed it up, you guys. How did we do that? Where did we mess it up at? What do you mean? What do you mean? That should be perfectly fine. Wait, what did we do? What did we do? Can I access local variable labels? Why not? We were doing it before. Hold on. Let's undo. Yeah, see? Right here. We were certainly doing it before. Oopsie. Oh well. Okay. Well, we're gonna have to retype it now. Oh well. Drink water, green vegetables. Yep, there you go. That's the way to do it. You got it. You got it, you guys. MTB or eMTB bike. Walking. Cronus is basically trained and well-tuned for trading. Oh, stock markets. Favorite food, broccoli. I think it's broccoli right now. I really like broccoli. I'm into carrots right now too. AGI versus RAG versus quantum computer. All different things. But the method behind is very straightforward. No way. I know, right? Prod by core. All right, so artificial general intelligence is an AI model that can perform at the level of a human, right? You can ask it to do something and it will be as good as a human, right? Artificial superintelligence is it dramatically outperforms a human, right? Retrieval augmented generation, RAG, is a way to interact with the model and give it additional context. So you can throw in a query and an engine will pull context from a data source, right? A database or something, and it merges that in to your prompt. That's an AGI. Quantum computer is a new kind of processor. It's like a standard silicon processor that has the ability to sample single atoms. So it's a single atom style, or a single molecule of some sort, like a photon or electron or something. And it allows you to measure it. It allows you to measure it. Do you like meat, like steak or burgers? Proud by core. I know, only vegetables. Actually, I do. I'm fine with meat. I just eat vegetables, you guys. I just eat those vegetables. You feel like a weird question, but how many years do you think military grade AI has advanced compute compared to the publicly available AI? I think private industry has eclipsed military grade AI as far as I understand it. And so what we're doing is we're trying to partner military-wise, states and countries will partner with private industry companies for state-of-the-art. Vegan, yep, we're doing the vegan. You're sure right, we're doing the vegan. Hypergraphs without vector embeddings, they seem to work just as well with less computational overhead. That could work. Yeah, that seems fine. That seems perfectly fine. We have to rewrite all our code that we messed up here, you guys, to torch.float32. You know what we could do? Let's reopen it and see if that works. There we go. I got it all back. I know how to deal with that. Okay. Managed very well to keep a journal. Pen with me always. Also, memo pad on the desk. Must say to keep journal. Pen guaranteed. You'll manage your life well if you've got your pen and journal. I used to walk around with one. I call it my algorithm book. I wrote down different Bloom filters, different hashing algorithms, buckets, B trees, self-balancing B trees, indexes, how to create indexes, how to do graphical effects like blur, make this, do a filter like a Photoshop filter. I've done those in real time, and I did it in a GPU blur. How do you approach unstructured data and design some deep neural network model for the data set you're working with? So there's a lot of different ways you could do it, right? One is you could try to extract meaning from the data and pre-process it yourself, which is supervised learning, right? You can do unsupervised learning, where you can sort of extract clusters of data where you can find similarities. So you can cluster data, and then you as a human have to create the labels and the outputs after it's done, right? So you find clusters. You can do clustering. You can also do unsupervised, where it can learn, and this is what large language models do initially. You give it just a bunch of text, and it will learn the order of texts across all of its parameters. And then you can go in to fine tune it, so that way you can create application-specific development, sort of like generative coding, right? You could do generative coding in that case. So that's kind of how that works. What's your plan for when the channel blows up on live stream and often filled with a lot of comments at a time? I won't be able to keep up. I'll try to read as many chats as I can. I will. I'll try to read as many as I can. Okay, you guys. We have 30 minutes, 33 minutes. We're good. Let's see if we can make this work. Okay, so these here, I'm going to grab our features and labels. Where do we go? Those features and labels here. So do we only use them here? We only use them here, I believe. So let's grab this. Let's delete that. And then I believe, let's not worry about that. I don't think you know what? We'll do it anyway here. There. Grab them there, and then we'll grab our features and labels over here. That way. There you go. There you go. Easy mode. Easy mode. Now we don't have to worry about scoping anymore. There we go. No scoping problems. Sorry for coming and not helping out with the Pytorch. I'll let him focus, guys. Yeah. It's all good. You're good. You're good. All right. Let's see. Now we should have no errors. There we go. There we go. All right. That's what we're looking for. However, I believe we need to print this out really quick. Let's make sure. I want to make sure that we didn't mess anything up. Nice. Okay. So this is what I'm looking for. That's the epoch. Here's our labels and features. And on the screen, this is where our output is to measure that. So that's what we're looking at right now. It looks good to me. It looks good to me, you guys. How is going your working life and personal life? I'm asking because mental health and burnout is a major issue. So you take breaks and on the weekend, right? So I save all of my house chores, like food prep and, laundry and things like that on the weekend. Save it for the weekend, you guys. And then do a little bit of maybe a video game or two, right? On the weekend. Spend time with friends on the weekend. Okay. So let's see if we can get our delta now. Let's see if we can get our delta. All right, you guys, what's this? All right, 0D or 1D target tensor expected, multi-target not supported for criterion on negative likelihood loss? Come on, Pytorch, you don't support that, really? Okay. How are we gonna deal with that? How are we gonna deal with that? How are we gonna... Let's go back to the tutorial and see what it wants us to do. Okay, so we can run it through the grad in a batch. However, we need to take the outputs and sequence them in the loss right here. Targets, prepare sequence, target scores, right? That's the output, but they're doing it on a per sentence basis. So they're doing it inefficiently, but it's fine because it's a tutorial. Who cares, right? Who cares? However, for the negative likelihood loss, or the NLL, right? The NLLL, 3 L's, negative likelihood loss, right? Where is that at? Where is our criterion? Right here. Negative log likelihood loss, right here. Right there. Negative log likelihood loss. So that's our criterion, our loss function. We need to use that here, but it's not letting us because we need to capture part of it independently from the answers. So let's take a peek at our answers real quick. So we need to, it only supports one sentence at a time, I think. One sentence at a time, okay. It can't do all three, which is really annoying. It's really annoying. I think we can do it though, because we could use a slice. Torch supports views on our data, so we can do a slice. So we should be able to do that. Let's do our slices. So for slice and, oh, you can't use the word slice. It's a reserved word, you guys. What's going on, Stephen? Joshua, hey, how's it going? What you working on today? We're wrapping up our LSTM, maybe. We're still messing with the data shape. So our tags or our output, which is our training labels, we need to get them in the right shape. Right now, our criterion only supports, I guess, one sentence at a time or one input sequence. I wanted to do a batch. It's not letting us do that. So what we have to do is we have to iterate over them. So let's go, how do we do this? I suppose we could say sentence in answers. Ooh, can we do that? Can we say len range len answers? Okay, like that. Looks good. And then we are going to, or how about this? We'll do labels. A little bit better. Say label. Label and labels. And then we're going to grab a criterion. And that gives us the ability to create a slice of the label. How about we say index? Index. Index. We don't need to do this. Labels. Wait. Oh, whoa, hold on. Is this program like Python? It sure is, Joshua. Yes, this is Python. You got it. The main focus here lately has been Pytorch. We talk about a little bit of everything here. We sure do, Bonzupi. We sure do. Let me try one more thing really quick before we give up on this approach. All right, so like that. All right, maybe. I don't know. Let's see if we can get it worked. Yeah, I figured as much. We tried. We're trying. Hey, Torva. Oh, Steven. If you've done with this, I made an update to the Discord bot. You can look at it if you want. Yes, I would. I would like to. You're the worst at coding. Oh, Joshua, it's so much fun. How's it going there? Thank you for clicking the hi button, Chaudhry. Or is it Harish? Oh, Harish. Hey, Harish Chaudhry. Good to see you. Welcome on in. Meet you tomorrow. Sounds good, the dreamer. Good to have you here. Also, you agree on the journal? Yep, and pen thing. There you go. Absolutely. I'm answering questions so that Steven could lock in. Thank you, Bunzupi. Appreciate it. So you said you put something over here in general? Let's see. What is it? Okay. If y'all are seeing the same thumbnail here, this is what I'm seeing. Cow. Is it working? Oh. Stream cord is still broken for some reason. Oh, we need to fix our stream cord. Okay. Torva, thank you for posting. Hey, Steven, how's it going, the doctor? Good to see you, doctor. All right, so, yeah, in general. Yeah, this is weird. It's very weird. If you're, you made an update to the Discord bot if you want to check. How do I check the Discord? Oh, sir, how do I check the Discord bot? What do I do to do that? I mean, I see a message over here in moderators. I'm going to go check the moderators here. Oh. See, stream cord. Oh, hey. Okay, so I can show this. I can show this part here. GitHub. Okay. Jupyter this month. Oh, like Jupyter Notebook? Like Jupyter Notebook? Yeah. Maybe you can learn a few things. Nice. Yes, that'll be a good plan. Very good plan. Type / view command list. Okay. / Do we have built-ins? Where is it? Do we see status / status? All right, yeah, we got the status there. On your Discord bot repo, I made a fork of the pull request. Oh, thank you, Torva. Thank you. Like a Kaggle for your Jupyter Notebook. Nice. Yes, that would be that's the way to use Jupyter Notebook. Okay, so where is the bot at? All right, where's our bot at? So let me see. Steven, GitHub. Here we go. And then I go to bot. Let's see here. Repositories. I'm throwing it off screen because I've got some stuff over you can't see. Discord. Bot. Here we go. Discord bot. Found it. Here we go. Okay. So you said you added something over here on the Discord bot. How do we pull request? Here we go. Torva, 10 hours ago. You added mod management in the Google API. If you want to add Nate, right there in the Discord bot. It's not necessary. It is not necessarily. Wait, what do you mean? It is not really necessary. It works without it. Just won't be a link to the respective channel. Don't update README. You can update it if you want. Okay. Oh, you didn't update the README. Got it. Okay. Very nice. Thank you. Let's see here. So you added some oh, you know what? I think my 1 second, you guys, my mouse, this thing right here, I gotta plug it in. It only takes 2 seconds. Here, 1 second, you guys, hold on. Torva, thank you for doing that, Torva. Got the cable. Plug in. I have to do this like every couple of months. The battery lasts a long time. It lasts a really long time. Okay, let's get back into it, you guys. I'm very interested. I don't have much time. I only have 20 minutes. And I really, 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 really want to get this done. Like a lot. Like I really want to get this done. All right, so where are we at now? Okay, so this doesn't work here. This will. I'm pretty sure that will work. Okay. So for index, labels index. So this is going to give us our delta per sentence, right? Per sentence. Do we get it? Oh, come on. For 1D input, 1D target must have size 1, but got target size 7? Scores and targets. Let's print it out. Print. Here's what we're going to print this out here. Okay. Comment that out. And we're going to print this. Print. And we'll only do one of these here. So print. Okay. Why it not work? We're almost there. We're right there. Delta not defined, not a big deal. Okay. See, that looks fine to me. You can't get it any different. Oh, well, let's think about that for a second. Well, we did. Are they doing argmax here? Prepare target scores. So we get the scores directly. Got it. So I see what we're doing. Okay. We messed it up a little bit. We can fix it. Yeah. Hey everyone, backpropagation and LSTM is awesome. You've been learning about them over the weekend. Nice. That's what we're doing right now. Okay. So I see what we did wrong. And we need to change how we're doing this. So we cannot do this. This is incorrect. Although as much as I'd like it to be, this is only for accuracy. It's not for loss. We cannot do that for loss. It's only for the target output. Hey, Mohammed. Hey, Steven. Good to see you. Welcome on in. Happy Tuesday. All right, guys. We only got 20 minutes left. Oh, so Torva. Really quick. Torva. For this code here, should I merge it or is it ready to be merged? Google API key. Discord. Hey, very nice. So that way we can mod directly from Discord bot. For now, I made it so you can add mods, name, and have locally saved database. That's every name. Oh, just look and update it if you want. I updated the README too. Nice. All right. README here. Okay. So you need to pass in API keys, Discord. Okay, so I need to grab a whole bunch of credentials. All right, off to take a look at that. Nice, very nice, Torva. Thank you, Torva. Appreciate it. Okay, so we're almost there. Okay, so we cannot mutate this. However, we can. So we need to change how we're doing here. Okay. So I need to get our output directly, and we don't have answers, we have labels now. So let's comment these guys out, and then only show this as out and labels. Okay. Let's take a peek here. Okay. Here we go. So we need to change this to make this match this. And then we're good. Right? Are we good now? I think we might. I think negative likelihood of loss. Hey, Neva, good to see you. Happy to have you here. You just need to fill out the role ID and if you want Google API key, but the API key is optional. Oh, nice. Okay. Nephew. All right. Neva, it's good to have you here. Excellent, Torva. Thank you. Okay. Great to see you. All right. So we need to change this up now. Let's change this up real quick. Okay, our labels need to be changed again. Oh, yet again, just in case. Let's save it though. So we're building our dictionary and we're building our labels, or to our tags right here. We need to create an array and then assign it to the element that's based on the answer. So we've got our data here. See, if not tag and tags, update for sample. Okay, so this is just building the dictionary. This is building the dictionary, so we don't need to worry about that. When we vectorize it, it's when we need to worry about it. So instead of giving ourselves this, we need to do something different. 0. Hold on. Oh, right here. Okay, perfect. Okay. So this needs to we need to create a new. So it's got to be like we got to add a dimension. Okay, there we go. So we added the dimension. Now we need to let's say tn, where is it? Our tags, range, len tags. Okay, right there. So we could do something like that. All right. 0 should be -1 there. No. Oh, should it? We actually could. We might as well. All right. -1. There you go, Neva. Thank you. We got a -1 now. Okay, so I think that'll do the trick. Let's print our labels now. See if that works good. Yeah, it sure does. It sure does. Okay, is that correct now? Yes. Okay. All right, now we got it. That's the right shape. We finally got it. The tag of 0 has meaning. That's a good point, because 0 will have a multiplication of, so you don't want to assign everything else to it. Got it. Okay. Yeah, that is one of the things. So when you have some zeros, it could mean deactivation in some cases, right? So we want to make sure that we always have some sort of value to represent that meaning, right? So wait. I suppose, well, we could do 1 to 3, right? Instead of a 0 to 2. Wait, how is your subtitles working? This is alive. I know, Hendrix, right? Isn't it neat? We've got our subtitles right here, you guys. It's magic. It's magic, isn't it? Yep, we wrote our own subtitles right here 8 years ago. Easy to install. Anasazi, good to see you. Happy Tuesday. All right, you guys, we have 15 minutes. Like there is a class with tag 0, but there is no class with tag -1. Well, it's up to us. We can define it. There is no class with tag 0. Okay. There is no class with tag. There is a class with tag 0, but there is no class with -1. Oh, yes. You're right. There's actually 4 answers. You bring a good point. Because if we set it to 0, it might think that the answer is actually 0. However, the answer could just be a mask. And so we need to put the mask at -1 as opposed to 0. Because 0 has meaning in this case. Great engineering and indistinguishable from magic. That's right, exactly. Great engineering is indistinguishable from magic. All right, let's get back to it. So now we've got the right shape. All right, now we got the right shape. I think we do. We better at this point. We better. All right. So it looks correct to me. So let's see if we can get our negative likelihood of loss to correctly work. All right, here. Let's try it. Let's try it. No breaks. No breaks this time. Still broken. Oh, we don't have answers. We have out. There you go. Easy, easy. It's still not working. Why not? What do you mean by the right shape? Here. So you can see that this is, so let's see, they should be the same shape and the same type. So that way they can be compared, right? Oh, wait, is this correct? That looks correct to me. That looks like you can compare those now, right? You can compare those. This is each word. So this is word 1, word 2, word 3, word 4. And there's no words that are down here, right? Because there's only 4 words. Or there are some words, maybe. I don't know. I don't know. Let's see here. Why isn't that working though? I feel like that should work this time. I feel like we got it all the right shape finally. 0D or 1D target tensor expected. Multi-target not supported. Break. Let's try just one. No, not even one. Not even one, huh? Not even a smidgen. All right. So now we're stuck. How are we going to figure this out, you guys? So we've got our tags, sentence in. We got our score output here. And then this is our negative likelihood loss, negative log likelihood loss. Tag scores and targets. Our output here, our targets, prepared sequence. Let's learn what this function does to see how far we're off. Training data, tags. That's okay, so that's fine. Okay. So it's only getting sample 0, 1? No. Why is it 00 here? Inputs. Oh, that's the input. It's only getting one word. Word to IX? This is only doing one word at a time? There's no way. There's no way! The numbers represented in the graph point to a multidimensional graph. If you plot the numbers on their respective positions on a graph, it appears as a shape. Yes. Yes. So basically, numbers collectively represent shapes and theoretical space. Yes, exactly. So let me print out their shape real quick so we can make sure that they actually are the right shape. Let's not break here. And then we'll print this out. So we'll do... shape. See if that works. Let's see if we got that. Okay. Okay, so we got 3 sentences, right? 3 sentences with 7 words, up to 7 words, right? With a mask, and 3 elements of each. So it's a 3-dimensional tensor that should work perfectly fine. And what we're doing is we're grabbing the first one. So let's say 0. Oh, no, wait. 0, 0. So we're basically doing the same thing here. Okay. So I'm going to grab this. Let's break on this real quick. So these pieces here, I'm just going to analyze them just very, very briefly. Oh, money. Here we go. Okay. So this is what I'm looking at right now. So we've got our size of 7 with an element of 3 in it. And they're the same shape. So... All right, we're really close. 10 minutes. Can we figure this out in 10 minutes? I don't know. I don't know if 10 minutes is enough time. It should be. So we've got a sentence or got a shape. Let's see what prepare sequence does. Because we wrote our own, so it might be different. Prepare sequence right here. So we're getting indexes. So we get 2IXW for word and sequence. So this is I believe, our words, right? The words and the sentence itself. For word and sentence, we need to look up the index. 2IX. And as IX defined, this is our word IX here. And then we generate an index set. So we tokenize, right? This is the tokenization. Famous last words, I know, right, Bonzupi? Basically, that's where we're at right now. So this creates our index of numbers. Tag 2IX. Let's see where we use this at. Oh, neat. Oh, neat. Okay. So then that is the target output labels. Really? So the negative likelihood loss already does stuff that we don't need to do? Are we just being a little too fancy? Is that what we're doing here? We're just being too fancy. That was great. Well said. Oh, Anasazi, I think Bonzupi said it very well. Yes. Bonzupi said it great. Okay. Get our inputs ready for the network. Okay. So prepare sequence is very easy function. This function does something very simple. It just takes pre-generated dictionaries and assigns them based on the word, right? So that creates the indexes. Okay. The index IDs, essentially, right? The tokens, the token IDs. And that works for both the output labels and the input features. So if that's the case, then maybe our labels that we generate were already good. So let's see if we can update that. Let's see if we can update that ourselves. Okay. So we're gonna save this old version. See, this is old underscore, and then we're gonna create a new one, and it's just going to be simple, very simple. We don't need this anymore. Where's that at? Hold on. Right here. Yeah, okay. So we don't need that or that. And then we don't need the 4 anymore. Okay. There we go. So now our output should look the way it does in the tutorial, right? So there's the way it is in the tutorial. However, I don't know. We're going to find out if that works. We're going to find out if that works. Here we go, you guys. Let's see if it works. It's very similar to the tutorial now. It's very similar. Almost identical. If not completely so. Here we go. Here we go. Ah, darn. Expected scalar type long, but found float. Where? Wait. Hold on. Oh, it doesn't want it. It doesn't want it to. That's why. We're trying to be too fancy, you guys. We're trying to be too fancy. You haven't explained what code you are writing. Oh, hey. All right. So what we're doing is we're creating a long short-term memory model. This is an LSTM. It's a recurrent neural network that holds hidden state that tracks positioning. Essentially its position, right? It adds dimensionality to sequences. So it adds importance to ordering. So order is important. That's kind of how I describe this model. And what you can do is you can create tokens with the tokenizer, essentially a word dictionary. And then you can create an output classification or output target class. I believe you could probably also use an LSTM to do generative token generation. I think you could. So you just need to have your target input and output size will be identical in terms of the number of classes that are supported. Steven, LSTM is always fancy. Is it? Yeah. Also, are you unfolding the LSTM? A little bit. Oh yeah, we did a little bit. So I followed the tutorial, except for instead of adding a dimension, I am throwing in a batch. So that way it throws in a batch, as opposed to giving it as a batch of sentences. So I can merge that back into the old approach to add a dimension with a view extension, which just adds, another dimension around it for the sentence. However, I wanted to support batches, and I got it to work. Yeah, they used to use LSTMs instead of transformers. So we could create a small language model, right? We sure could. Precursor to the transformer. Okay, you guys, I've got 4 minutes left. I've got 4 minutes. And here we go, the best song of the day. Just in time. Why are you coding besides just learning? Yep, we're just learning. You got it, Jacob. We're just learning. I want to become an expert at Pytorch. I'm already okay at AI. I've written my own networks many times. JavaScript, Python, Rust. I've written 3 separate neural networks, deep learning. Lock in, Steven. All right. Let's lock in, you guys. Okay. Let's see if we get 3 minutes. 3 minutes to go. I forgot what we were doing. Where are we at? Okay. Let's just print to see if we fixed it. Looks like not. Oh, right. Okay, right. Let's rate labels. We don't need to detype it. We just need this. Here we go. Let's try it. Nope. Target -1 is out of bounds. -1? Oh no! We can't do -1 here. All right. /- -1. We're going to do it differently. 0. We'll say 0. There we go. We did it. Hey, you guys, check it out. All right. Finally, no error. Wait. Yeah, we did it. We did it. We did it. Hey, we did it perfect. Just right. Like in the last 3 minutes, you guys, the last 3 minutes. All right, let's delete all this stuff that we don't need anymore. All right, now we don't need to break this anymore. Hey, we did it, you guys. Check this out. All right, now we can do some back propagation. 0 mean to arbitrary class, so you have something weird in the code. We need to, yes. So we could add another class is what we could do. So tags length, like tags here. Tags. So we can create another tag that supports something else. We could. Probably says you have a bug. It's actually, I think we're okay. It just means we'll misclassify something, right? So I think it's okay for now. I think it's okay. So here's our input data. Here, I'll show you. So let me open up LSTM. Here we go. So here's our tags. So that's what our tags look like right there. And then our dictionary is here. So yes, we'll have a problem with this right here. For our mask is 0. Our mask is 0. You're gonna misclassify stuff with the 0. I know, you're right. We're gonna misclassify it as a noun. However, it's actually perfectly fine. So what we could do is, let's see, how do we do this? Right here, init, right here, dictionary, hidden dimensions, embedding dimensions is going to be, no, not 12. What is our target classes? Where's our classes at? Number of tags. Here we go. Tags. Tags plus 1. Let's try that. Let's try that. We'll try it. We'll try it. Real quick. One last thing. If it doesn't work, we'll have to go back. -1. 30 seconds. And, oh, it doesn't like that. Oh, of course not. There we go. Yeah, okay. Well, don't worry, Neville. We'll figure it out. We'll have like a pad or something. We'll throw a pad in there. What we should do is, we should do this. Here, I'll just update it. So this will be pad, mask. There we go. There, Nevin, there. Happy? Yes, really override it. Yes, really override it. There we go. There you go. We don't need that. All right. Then we don't need to do -1 anymore. -1 will be 0. There, nothing misclassified. Never, we did it. Now we're good to go. All right, so tomorrow the plan is we will be training this model now that we've got our ability to generate gradients, finally, after mini streams. What was the reason for wanting to learn this? I'm very fascinated about it. It's a lot of fun. It's great. Also, it's the topic of the world right now. AI! That's what we want to learn. You're helping, Neva. You're helping. Thank you. Next stream, maybe you can add matplotlib to visualize the tensors on a graph to illustrate how the numbers represent points in the vector space. That's a good idea, Von Zupi. You guys are great help. Have a good one. Zergio, thank you guys. Had a lot of fun. I got to jump to a meeting now. I'll see you guys tomorrow. Steven, learning stuff for fun. Exactly. Yep. We're learning it for fun and for awesome. That's right, Anasazi. All right. They have, you want CFA? If you want it, don't forget to soak your beans, you guys. I know, right? Overnight soak at least. Git commit -am. We did it. Push main, boom, done. It's been a pleasure, you guys. Had a lot of fun. On the next ticket system, next few days, you will probably pull a request. And then, anyway, hope you all have a great rest of your day. Good luck. All right, you guys, had a lot of fun. Bonzupi, or else get gas. That's right. Expensive gas. Thank you, guys. See you guys tomorrow. Bye, everybody. Wait, where'd the stop button go? I can't. All right, there we go. All right, bye, everybody. See you tomorrow.